The purpose of software engineering research is to find better methods, methodologies, tools to help us to develop high quality software products. For example, the famous waterfall model, which is used to help us to systematically develop software, which includes few phases. And the CASE tool, CASE stands for Computer Aided Software Engineering, is a technique for us to use computer to help one or more phases of software develop life cycle. It involves software tools, trainings for developers. A formal software development life cycle is divided into 7 to 9 phases, including specification, design, risk analysis, verification, coding, testing, refining, production, maintenance. All phases are important, although there is no documentation phase inside this one. However, documentation is embedded in almost every phase. The first phase is called specification. In some textbooks, it's also called requirement analysis. The, the documentation of this phase is a contract between customer and the software developer. In this phase, we need to understand what kind of functionalities the system should provide, and the prototype may be involved. We may also need to understand what are the input output data, which data are valid, which are invalid, who are going to use the software, and how will the user interface look like. For example, for library system, we need to understand the input. For example, librarian enter new book when the books arrive, and people use the searching function to search the list. We also need to understand the output for the library system. For example, what kind of information we should present to the customer who is searching the catalog. And are there any time space requirement for this system? Are there any other processes we need to think about? Once specification phase is done with clear detailed documentation, we move to second phase, design phase. During specification phase, we were trying to understand what kind of functionalities the system should provide. In design phase, we try to understand how to provide those services, how to provide those functionalities. One common approach is called modular design. We apply divide and conquer to divide a big problem into smaller, manageable parts, which is called modules. For each module, we need to understand what are the output, what are the input data. For example, for library system, after design phase is done, we come out with these class diagrams, which include 7 classes for the system. Each class represents one module. In this phase, we need to understand there is any risk associated with this software project. For example, if there is any key programmers are leaving, is there any chance that company who is providing the hardware for this software becomes bankruptcy? In this phase, we need to understand there is any risk associated with this software project. For example, if there is any key programmers are leaving, is there any chance that company who is providing the hardware for this software becomes bankruptcy? Although the risk analysis is important in industrial projects, however, it's not less important for this course. Verification is a very common phase in industrial projects. During this phase, we need to use a formal approach to prove our design is correct. Implementation, also called coding, is a relatively small phase in software development life cycle. During this phase, we try to translate our design or code algorithm into code by using certain programming language. We should move to implementation phase once we have a complete, correct design documentation. Nowadays, we have very nice software tools which can help us to translate the design into code automatically. Although we have a separate testing phase, actually testing is embedded in every phase: design phase, specification phase, maintenance phase. There are many testing techniques, including black box testing, white box testing, system testing, integration testing. Testing is very expensive. We need to well design the test data in order to achieve effective, efficient testing. Even with the same test data, we may need to test several times on different situations. Also, once we modify the software, we need to retest all the test cases. In design phase, in order to make our life easier, sometimes we make assumptions. In refining the solution phase, we need to remove those conditions to increase the robustness of the software. For example, in design phase, we assume the input will be integer between 0 to 1000. In this phase, we need to remove that condition, try to change the software to allow the software to accept all different kind of integers, not only integers between 0 to 1000. In production phase, we will install the software into customer computers and then perform customer testing. This stage is important because the customer computer may have different environment than the developer computers. Once software is delivered to the customer, any changes to the software are called maintenance activities. There are several kinds of maintenance activities. For example, if there's a bug in the software and correct those bugs is called correctness maintenance. Sometimes the customers may want the software to be used in a different environment, different platform. We need to modify the software as well. It may be the case that customer want to add a new feature to the system.